Welcome to our battery test lab. This is where we do all of our physical testing. But I'm here to tell you today about our computational and simulation capabilities, a key step before we reach physical testing. So the whole idea around computer-aided engineering and simulation is to basically enable you to engineer the product to just meet a specific design margin. And what I mean by that is anyone can design a bridge. It takes an engineer to design a bridge that only just about stands up. It's the same thing with CAE and simulation. It lets you understand and test things to their limit in a simulated environment. And the big advantage of that is it's exponentially faster and cheaper than reaching a sort of physical test scale. You prove out thousands, hundreds of thousands of scenarios in a computer or a simulated environment, and then you physically prove that out in a real test environment where we stand here today. So we've actually built quite a strong capability in-house. We've got some very experienced and very senior engineers that are both of them at doctorate level, and in fact a whole team beneath them again supporting them. So to have this capability, you need decades of experience and you need a very strong theoretical basis to understand what you're doing in these simulated environments and using these very sophisticated tools.
If you're to do a Venn diagram, you'd see simulation, testing and analytical. And you have to have all three components for an accurate model and an accurate idea of how your battery is performing.
So simulation is a good way both to fully understand the problem and also to cut cost. I get things like this. Somebody comes and like, oh, we've been testing this bit of manifold and it's burst. Yeah, why did that happen? And so I take on models and analyze it and then find out what happened. And therefore, how we can prevent it happening.
With all these fatigue calculations and also with the cell temperature calculations, we can predict how the battery will perform out in the field very, very well. And we can basically virtually induce different environments on it. And by virtually inducing different environments on our virtual battery, we're able to predict how well it will perform in the field and make sure that it can survive and withstand any condition thrown at it.
Our simulation guys don't just hide behind a computer all day. They will be in the test lab. They will see, hold and touch a lot of what they are simulating in a virtual environment. That's critical. That building that link from the virtual world to the physical world is one of the most essential pieces of CAE. And that's why you have to have it in-house. That's why you have to have a mechanical design engineer, an FEA analyst, all side by side. CAE is a critical tool to enable you to build the best possible product, the most optimum product, at the best price, the best performance that the customer wants and needs.